Seismic loading is a real concern in a lot of areas in the world. Now, when you think about timber and how it stacks up against other materials, it's very lightweight. So that's half the battle. Having a lightweight building is going to reduce that seismic mass, regardless of the size.
The mass of the building creates its own inertial force, and so usually a percentage of that total weight of the building becomes a horizontal force that starts to make your building sway. So the heavier your building, the bigger that horizontal force. Mass timber, again, compared to, say, concrete, for example, is a fraction of the weight. So fraction of the weight in vertical sense means you have a fraction of the weight in the lateral sense, which means you have less load to deal with.
Now, the other part of the equation is how well you can resist seismic loads. And the challenge with seismic loads is you don't stop shaking when you're done, you stop shaking when the earthquake is done. And the issue is how much energy you can dissipate. The challenge for mass timber is that energy dissipation, regardless of building framing types, happens through steel connectors.
The opportunity now is to go above the code design and design these buildings out of mass timber, which are a third the weight of concrete buildings, and for seismic zones, into a resilient design where they can move, they can shake, and they can come right back, and you get exited, and you come back in 2 weeks, replace some sheetrock, and you're home again.
You have to respect the material and use it technically, and we still have so much to remind ourselves about the viability of wood as a structural system.